Hi, everyone. So I don't want to look behind me on the whiteboard. I can tell it's going to be something awful. You may think it's awful because I think you can see over my shoulder right now. Let's look at this together. Here we go. Oh gosh! Oh my gosh! Oh! Oh! Okay. The binomial theorem, BT01. Okay, so the good news is you don't really necessarily have to know this. Okay, now what are we doing here? Okay, the binomial theorem is an easy way, and I say easy, easy, okay, an easy way to expand higher degree polynomials. This is a nice color. Okay, it is a way, an easy way, it really is easy, to expand higher degree polynomials. So let's just take what we know for now. Clearly, if that n was a 0, it'd be simple because everything inside would just be 1, right? If that was a 1, it would just be whatever's out here. If this was a 2, and this is the one I'll write, so if let's say we have x plus y to the square, that's really x plus y times x plus y, and then we could FOIL the binomial and go from there. Now, let's say that was a 12. I would just write 12 of those. Now, you could just keep foiling and foiling and foiling and multiplying binomials to get the answer, but that's going to take forever. We're going to get really good at Pascal's triangle. These two are linked forever in love, okay? So Pascal's triangle is a way for us to quickly, easily, because this is not quick nor easy if I had 12 of these, find out the expanded form, the complete expanded form of a higher degree polynomial. Okay, so we'll talk about this more in class, but the triangle itself is a triangle, all right, and it goes infinitely. So basically what happens is I can get a further down row. These are rows, 0, 1, 2, 3, 4, and that obviously represents the n value or the exponent value. So for example here, 6, right? So 6a squared b squared, I get this result by taking the two, the level above, the two that would give me a triangle. So 3 plus 3 is 6, and that's how it would make my square. Now, the values of the exponents also have a pattern to them, and there's an easier way that I'll explain in class. 1 and 3 is 4, and then so on and so forth. So for example, if I were to try to get this value down here, 4 and 6 would be 10, okay? Now, the way that this works is we kind of take turns with the values. It doesn't matter what this value is, whether it's a variable or a number, and it doesn't matter what that is. Now, it will matter when we finally get to the expansion of that because we have to put it in standard form, but I'll talk about that again in class. The a term, it's always going to be to the 4th power if my exponent is 4. A to the 4th, b to the 0. Then it goes from a, it goes down an exponent by 1. But the b value goes up by 1. So there's a give and take there. So a4, b0, a3, b1, a2, b2, a1, b3, a0, b3, okay? And that's how that process works. And again, there's a table that I'll have you fill out that's really makes this a lot easier. And it will help us go all the way to the 10th, okay, or the 12th, or 14th, or whatever, or the 100th, okay? I probably won't do that because that would be devastating to you. But basically, the binomial theorem, forget about this nonsense right here, but the binomial theorem is an easy way for us to expand polynomials with higher degrees. And Pascal's triangle, we'll be able to work that process out too. So I'm going to give you some examples in class, and we will go from there. Your quiz itself, look up Pascal's triangle, or even use this, because I think the highest one I go to is 5. So see if you can figure out the pattern, all right? See ya. Whew. That was scary. I think I scared the dog. All right, where is the dog? Diane.